a little bit less.
There we go.
Okay.
Woohoo.
Right.
So, Guy, you're missing some nice warm weather.
So I hear. We have our own warm weather. No, that's
It's not too bad.
It's not too bad.
It's picking you up okay.
Okay.
We've all
So, Guy, in the last 2 weeks, I've bought a new computer and I have a new car.
Wow.
And they say I now know why I only buy a new car every 20 years.
Larry, did your Toyota finally went?
Let's put it this way. The trade-in value for the car was half of what I had to put in for repairs a month ago.
Okay. So what did you go with to get with the new one?
Corolla Cross.
Oh, very nice. Yeah.
So basically, it's the same. I mean,
Yeah.
the Matrix is a Corolla.
The Matrix was a Corolla. Was a big Corolla. Yeah.
And so it's the same thing, except the new one is like 5 inches longer, 300 or 400 pounds more, and it's hybrid. So I've got a.
Oh, it's a hybrid. Okay, so it should be the same. Better MPG than your smaller Matrix.
By a lot, yes.
Right.
But it's getting used to the fact that when you turn the car on, it doesn't make any noise.
Right. Yeah. It's like a golf cart when you're driving it below 5 miles an hour.
The screen, and I'm not used to any of these things, so.
I know. Well, are you're an iPhone person, I think, or Android, but either way, it's got Apple CarPlay and Android Auto and all of that sort of stuff.
Yeah, so I've got to figure. Our daughter is coming over probably Monday to help me figure it out.
It's pretty straightforward. Once I will tell you this. Even my father got the hang of Apple CarPlay, which is saying something, and now he uses it all the time.
But it's amazing. It is substantially, a little bit larger. So it's still a small vehicle, but it's definitely larger.
Well, hopefully it lasts as long as the Matrix did, because I always liked matrices. Same license plate, I hope.
In theory, yes. The dealer took it off the old one and put it behind the temporary plate.
Okay. All right. So hopefully that'll, you can't lose that.
I'd like to lose it so I can get one that isn't 30 years old.
Oh, okay, but a new plate, but with the same personalization.
Yes.
Well, I'm waiting for Adam to show up. Basically, what happened was we have just finished a grand tour of our visitor center. I think if I hold this closer, you won't hear the echo so much.
There we go. Oh, that's much better. Yeah.
Right. And anyway, we just had a tour of the visitor center, and we weren't sure if it was going to be over by now or if it would still be going on. But Adam was supposed to be showing up here at about now. But he's walking here from the Papal Gardens, and I told him it would be okay if he was a little bit late, because we usually do a round. We'll see how many people actually show up. The letter went out late this morning for understandable reasons, but it happens. So
I'll be curious, with sometimes a last minute letter actually can, it can be a benefit, because then people don't forget about it. They say, oh yeah, look at this, I can do that.
We'll see.
What time is it? We've still got a few minutes.
Oh, Carmen.
Hi, Larry. How was your Mount Graham adventure?
It was interesting learning the new system.
Right. Actually, Larry, I just got a note from Paul Gabor. He won't be able to make it. So
great, thank you. So I get to report.
So can you kind of make up a spur of the moment report of what it's like using the new system?
Yes. Only one major crash.
Well, that's pretty good for a new system.
Yeah.
Of course, one hopes that isn't the same for your new car.
We better not be, yes.
We missed you on Monday, Larry. Yeah.
I'll be there this Monday.
Yeah.
But I won't be there the following Monday because I'm doing a workshop.
And actually, Chris, where are you now?
I am in Canary Wharf, London.
Oh, okay. But then that we'll do the whole where everybody is when we're
Right,
all
when
lined up.
when the time comes.
Right.
So am I the only one in Tucson?
At the
Or-
moment, it looks like it, yeah.
At the moment, yeah, I guess you are.
And I guess everybody is going to be complaining about how hot it is, except for Carmen.
And I guess well the Brits here would be complaining about it because it's 25C 77 F, which is a heat wave for these folks.
Okay. Well, we're a minute into it, so why don't we do just a brief round robin, where you are, what the weather's like, and if you saw anything interesting in the sky this month. So we'll start with you, Bob.
Microphone on. There we go. Hi there. I'm in St. Clair Shores, Michigan, or I'm sorry, Clinton Township, Michigan, close enough. And it is sweltering. And we had torrential rains, what my wife would call gully washers yesterday, and flood warnings. We'll say we had heat advisory, flood warnings, air quality warnings. It was just a joy.
Have you ever been able to see anything interesting in the sky?
I saw coming home from the WASP meeting, the Warren Astronomical Society meeting last night. I saw the full moon or almost full moon just above the horizon, and it was really red, like it was red back when there was volcanic ash in the air. Is there something going on with the air quality right now?
Could be.
Could be fires.
Right. I'm in Rome. I'm in Castel Gandolfo. And even though it's cooler here by 5 degrees Fahrenheit from Rome, it's still around 90, which is hot for us. As I say, we had this place open, and one of the telescopes we have here is an 1891 Carte du Ciel telescope. And Claudio Costa had it set up looking at sunspots. And there are some really spectacular sunspot groups on the sun right now.
Image of those was crazy.
Right. Larry, tell us about the weather there.
This is Larry Lebowski in Tucson, Arizona. We're into 20 or 25 days in a row of over 100 degrees. It's cooling off today. It was 110 yesterday, though. The record for that date is 116. But I think the temperature over 100 is pretty much a record for so many days in a row. And sorry to say it, but we had humid weather yesterday. I think the humidity got up to 15 or 20%.
Oh, no.
Yes, because it was cloudy and we actually heard thunder. So there are monsoon storms in the east.
They're around.
Have they arrived yet in Tucson, though?
No,
But soon.
I don't know what the situation
right.
is on the mountain where Paul is.
Okay, Reverend James.
I'm in my hometown of Manchester, Connecticut for my weekly respite. It's 90 degrees here. This area is in another heat wave. I guess it's the first of the year. As far as interesting things in the sky, in my backyard last night, I was able to see the moon behind a series of trees. And because the trees were in front, you could notice it moving against the trees. So I pointed that out to my brother because it's really cool. And I also noticed it seemed how low the moon seemed to be in the horizon, or closer to the horizon than it usually is.
Okay, Chris, tell us where you are.
I'm just arrived to London, England, where it's 77 F25C. I haven't seen much of the sky. I did see a star, though, which you'll see. I'm going to stop my video. You'll see the profile picture there. So thank you, Brother Guy, and everybody for making that happen. So yes, that's where I am, and it's sunny here. All right, thank you.
And Carmen, how hot is it in Uruguay?
Well, we have 10 centigrades. The winter has come, announcing its arrival with a huge storm from the Atlantic. So this is it, a cloudy sky for the whole week. Thank you.
Okay, I had to leave briefly because our guest of honor has just arrived.
It's okay.
And we're going to hold this close to hold down the echo so much. So, Fernando, where are you and what's the weather like there?
Hello, I'm at home in Munich, Germany, and it's a warm afternoon, but it seems that there is a storm alert coming in the next minutes. So lots of rain tonight.
Okay,
And,
you've been getting a lot of rain this summer, haven't you?
we're waiting for the summer. It seems to be a very long winter for the moment.
Okay.
Yes. And this week I've watched the sun with a small H alpha telescope that I have here at home, and I can confirm plenty of flares, spots, and protuberances. It's very active.
Wow. Okay, Gary.
Hi, I'm in Milwaukee, Wisconsin, in the U.S. It's warm and humid here, of course, and I've been watching the moon at night because that's about all I can see. We've had this humidity that either means cloud cover or haze at night, and so not a lot of stars to see.
Okay, Kelly.
I am at the Virginia Center for the Creative Arts right now in Amherst, Virginia. We had a beautiful moonrise last night. It's super hot here in the 90s and very clear. The moon was pretty pink. I read an article that said it was the strawberry moon because of the low trajectory in the sky aligning with the solstice. So but yeah, definitely seeing color in the moon and very low on the horizon, which is really pretty out here. It's kind of rolling hills and blooming flowers. So it's very much like a fairyland.
Wow. Am I the only one who thinks of Pink Moon and a certain record album?
Nick Drake.
Yes, all right. I actually know a fellow in Glasgow, my age, who bought that record when it came out. I think one of the 5 people who bought it. It's, of course, now a bestseller now that Nick Drake has been dead 40 years. Mark, where are you?
I'm in Edinburgh, Scotland, where it is 17 degrees and drizzly. Today's the 21st of June, obviously, but it's the longest day of the year, supposedly one of the hottest days of the year, but it isn't happening. It's been like this for days. And I haven't seen anything in the skies since I've been living here for 20 years. We've had 20 years of cloud cover, pretty much.
Does it ever get really dark at this time of year where you are?
No. You get about 5 hours of darkness, and almost as soon as the sun goes down, it comes up again. So it's nice though. It's nice. You get used to it very quickly. Most people really like this time of year. So
okay. Jim, where are you?
2 weeks ago we had the Northern Lights, and everyone was out in the streets staring up at the Northern Lights, and that was something to see. So that was fantastic.
I'm envious. Jim.
I'm in Anthem, Arizona, just north of downtown Phoenix. It's hot. It's going to be, where I'm at, around 110. Downtown Phoenix is going to be near 115. So we're in the middle of our heat season.
I remember when I was learning Italian, and the only language everybody in the class had in common was Italian. And the instructor said, everybody tell me something about your home, because we were all, of course, away from home. And I had seen that on that date in June 93, that it had reached 120 in Phoenix. And so I said, nel mio paese il tempo era 52 gradi, 52 degrees. And everybody laughed and said, no, you've got the numbers wrong. You must have meant 32 degrees. They didn't believe me. It really was 52 degrees.
It does get that hot, yes.
And Alfred, what are things where you are?
Okay. Got here a little late and I'm not ready yet. It's just south of the Twin Cities, Minneapolis, St. Paul. And it's been raining a lot here, but it's about 70. I haven't checked the actual temperature yet.
Okay, so that's not too bad. I just had a group here from Austrian television this morning doing an interview. I refrained from trying to use my German, though.
Oh, that's great. What, just interview you as astronomer?
They actually originally wanted to interview me about the meeting, which I've not been attending. But we do have our guest here who'll tell us a little bit about the meeting that's been going on here. But before we do that, Larry, can you fill us in on what's been happening at the telescope?
So the upgrade to the telescope, all the software, the hardware, etc., is pretty much in place now. And the last 4 weeks or something, Paul Gabor has been up there putting it through its, training, making sure everything is working okay, and then having observers come up, learn the system, find out what fails, see what we're missing. And it's doing okay. We found out that the telescope doesn't balance as well as one would like, and it's probably more this new system is more sensitive than it was, so it complains a lot. And we did have one failure, but it was a good failure because it was a communications failure. So the system said, we don't know what the weather is like, we're going to shut down, and it did it properly. So it was sort of a good test of the system. But it's weird that you can push 1 or 2 buttons and save about 45 minutes of walking around the building, turning on things and making sure the pumps are working and opening the dome and other good things like that.
Let's see if I can do from memory the things that you would have to do when you were starting up the telescope. You would have to go downstairs and turn on the oil pumps. You would have to go upstairs and start the fans. You would have to open the telescope cover. You would have to turn on the cooling system, which was really tricky because you had to do 2 things simultaneously. You had to turn on fans someplace else. You had to straighten out the telescope. You had to actually make sure that the plug was holding the. It took, as you say, no exaggeration, 20 to 25 minutes.
There was a large thing you had to undo, bolt you had to undo. That was the short between the dome and the rest of the buildings, basically a ground for the telescope dome. Make sure it was balanced properly, etc. The big thing is that it has absolute encoders now. So you don't have to, if you can't lose where the telescope is, where it has no idea where it is. And so you can point and just say, go to these coordinates, and we'll go there within about 3 arc seconds.
That's right. So you don't have to redo that every night.
You do not have to redo that every night and because we were very good at getting lost. Where you knew where you were to within about 2 or 3 arc minutes.
Yeah, that's incredible. The part of the difficulty was that the field of view of the camera was only 10 arc minutes across. So if you were more than that away from your object, you had no idea where you were off. You just knew that you were off.
That is correct.
Anybody who's used a small telescope knows how frustrating that can be. Well, it's even more frustrating in a big telescope.
So yes, and if you can look behind me, that is T Corona Borealis, one of the images we took. And it's not in its nova phase. It's basically, that's a 10th magnitude red star.
Fabulous. So it hasn't gone nova yet.
No, it hasn't gone nova yet. When I first saw it, I thought it had, but it's just, putting it in perspective. And the other thing that the telescope does do, it does track. So we were able to pick an asteroid, go to it, and it was right there, and track on it, and it comes out as a dot, which is what you want.
So are we ready to say no one ever needs to go to the telescope anymore? The robot will take care, our robot master will take care of everything?
If you have a robot there who will fill the dewars with liquid nitrogen, yes. And the answer is so, therefore no. It's going to be a while yet.
We still need to get the new camera that doesn't need the liquid nitrogen.
That is correct.
Are there human beings on the mountain so that if there's a catastrophe, someone can run over and pull the plug?
Yes, but in theory, the telescope should be able to do that on its own. It should be able to go into light. You should be able to put it into a lightning shutdown and other good things like that. It does have, push this button for a lightning shutdown. And also, I think the lightning startup still has a few kinks in it.
That's fabulous.
But it's getting close.
That's wonderful. Well, now that we're all here and Adam is here, so I'd like to start by introducing our guest this month, Adam Hincks. Adam, tell us a little bit about yourself. First of all, today, where are you? What do you do? And why do you do it?
Well, right now I'm at the Vatican Observatory here in Rome. I'm an adjunct scholar here. And so I like coming for a few weeks every year to spend some time here.
Where do you come from?
I'm originally from Toronto, but that's where I'm based right now. So I'm an assistant professor at the University of Toronto. My primary appointment is in the Astronomy and Astrophysics department, not surprisingly. But I also have a chair that gives me an appointment at St. Michael's College, which is one of the founding colleges of the university and is Catholic, and we teach courses on faith and science there. So part of my teaching responsibilities is there.
Which means that apparently you have some sort of religious background.
Yes, yeah, I'm also a Jesuit priest. So I belong to the Canada province. I was ordained to the priesthood 5 years ago. Did my studies in theology not too far away in the middle of Rome. Yeah.
And at that point, you're also in some way affiliated with us. I understand that you came out to visit in an unusual way once.
Yes, yeah. It was soon after I got to Rome. I looked on the map and saw how far away is the Specola from the city center, which is where I was living. And I figured I could walk it. And that's how people would have gotten here. Unless you're rich, you would have ridden here on a horse, but ordinary people would have walked this distance ordinarily. And you can do about 2/3 of it along the old Appian Way, along the old Roman road. So I think it was June, and kind of the temperatures that some people were describing. And when I arrived, Father Paul opened the door, and I think I was just drenched in sweat. And he said, "You can use my shower."
The walk was easy until you had to go uphill.
Yeah, the last third, well, it's not a steep hill, but it's kind of an incline for about 6 or 7 kilometers.
What's the kind of astronomy that you do?
I'm a cosmologist. So in particular, I work with the cosmic microwave background. That's the light, that's basically the glow soon after the Big Bang, before there were stars or galaxies, when the universe was still very hot, very dense, and kind of like a star, like the whole universe was kind of like a big star, just glowing, and we can see that light today. The reason, when you look up at the sky, the reason you don't see that glowing is because the light isn't visible light, it's microwave light, hence cosmic microwave background.
So are you a theorist or do you observe, or a little bit of both?
I'm more on the observing side. So one thing I do is work on new observatories to measure the microwave background with more precision. So right now that's the Simons Observatory, which is a multi-telescope facility in the Atacama Desert of Chile. And we have 3 small telescopes and 1 big telescope, because they're good at doing different complementary science things. A couple of them were kind of commissioning, so they're starting to observe, and then the big one will start observing next year. And my group is working on some of the software, basically to take the data from its raw form through to something that you can use scientifically.
What's the big question that you're working on? I thought, the Kobe mission and all those other satellites had done everything.
No, there's still lots more to do with the microwave background. So I'd say there's lots of stuff you can do, but maybe a couple of headline things. One really big question is, what set the initial conditions of our universe? So one really surprising thing about the universe is how well behaved it is. When we look at the microwave background, we look at the very early universe, it's incredibly smooth, but it has these tiny little ripples, and those ripples, gravity acted on, And over time, that's how galaxies formed and stars formed, because there was little ripples early on. But those ripples are kind of just the right size. They're on top of a smooth background. And kind of one question is, well, where did that come from? Like, why was the universe so well behaved out of the Big Bang? And one theory is called inflation, which says that everything got stretched out phenomenally fast within the first second. If that happened, there should be a very, very faint signal in the microwave background, so faint that no one has been able to detect it before. And that's one of the signals we're going after. So if we're able to measure that, we'll be looking at how the universe was behaving. I'm not going to say all the zeros. If you know scientific notation, it's 10 to the minus 34 seconds after the Big Bang. That's kind of the era that we're trying to probe. So that's one thing. I can tell you about some others too, if you're interested.
But that gives me a sense.
Yeah.
How did you get into this? Where did you learn how to, be interested in observational cosmology?
Well, I did my bachelor's degree also at the University of Toronto. That's my hometown. And one summer, I got a research job with a professor. His name is Bart Netterfield. And he does cosmology. But the way he does cosmology is using balloon telescopes. So it turns out, as you might know, observing from the ground is great, but one of the problems is you have to look through the atmosphere. And at all wavelengths, that poses various challenges. Ideally, you want to launch a space telescope, get above the atmosphere altogether. But a cheaper way of doing almost as good is to get a really big helium balloon and dangle a telescope from the bottom. And you do a lot of clever engineering to be able to point the telescope and so on. Anyways, I was working on preparing a balloon-borne telescope called BLAST with him. And I just really found it fascinating that you could be working on this amazing instrument that would be saying fundamental things about the universe. Then that was the last time I worked on balloons. I spent 2 summers with him, and then I went to grad school and worked on ground-based telescopes.
So where did you do your grad school?
At Princeton University. And when I arrived, the Atacama Cosmology Telescope was just starting to be developed. So that's at the same site where the Science Observatory I mentioned earlier is, in the north of Chile at high altitude, 17,000 feet. And so my graduate studies—
It's what, about 6,000 meters?
5,192 is the official altitude, yeah. Okay. So that's about half the atmosphere of sea level. So the air is quite thin, but it's still breathable.
And so what was the work that you did, your graduate work on that telescope?
Yeah, so a bunch of things. I worked kind of on the instrument. So speaking of getting, 1 arcsecond pointing, one thing I worked on was the interface between the pointing control and our own software to move the telescope around. I worked a little bit actually on our camera, on the detectors, which we worked on in-house at various institutions. And then I worked a bunch on the initial science analysis. So one thing that the Atacama Cosmology Telescope is really good at is, in addition to seeing the microwave background, you can also detect clusters of galaxies. These are the largest gravitationally bound objects in the universe. And I led our first paper where we reported that, hey, we're seeing these galaxy clusters just like we expected.
Now, there's a question I've always had about people who build instruments and the like for theses, that what makes this different from just being an engineer? Is there anything in knowing the astronomy that affected the way you built the camera? Is there anything you knew about how the camera was built that affected the way that you interpreted the results? How do those interplay with each other?
Yeah, that's a good question. I'd have to think about it for a more profound answer. But I think, and I should clarify that now I don't really do hardware work. I do more software work, if you're talking about instrumentation. But I think a good experimentalist is kind of a jack of all trades, in the sense that she or he is just good at solving problems fast. A good engineer can do that too, but the astronomer also knows what the science goal is. So for example, what's the noise level we need to achieve? What astronomical objects will we use to calibrate, and will they be suitable calibrators for the for the hardware, those kinds of questions. But one thing that was really rich about it is that, yeah, you learn a whole bunch of different skills. So I learned how to do helium transfers. I learned how to interface with a commercial robot software that was pointing our telescope, things like that.
You've got students now, I take it.
Yes, yeah, I have. I currently have one PhD student. I co-supervise one postdoc, and I have 3 undergraduates working with me this summer.
Ah, sounds great. I'd love to be an undergraduate again. Now that I know all the things I was missing when I was an undergraduate. Well, let's go back a little bit then. You were raised in Toronto. What's your family like? What would they do? How do they think about you being an astronomer?
Yeah,
How's that route?
Well, that's interesting. So I'm from a Catholic family. So that's kind of been that was my upbringing.
Hincks is what background? German?
Hincks is English.
Thank you.
So it was actually my mom's side of the family, which has Irish roots, that was Catholic. The Hincks is English. And my parents were both English majors. So they've kind of been wondering where the science came from. There were, my great-grandfather was a physician, so maybe that explains it. Yeah, so they were very supportive of my choice to do physics, even if they didn't understand where the genes came from, maybe, and also very supportive of my religious vocation.
It's always a question that I get asked, which came first, and I don't know that I could identify it for myself. Can you?
Yeah, I think that's the right answer, or that should be the right answer if we're integrated people, right? That it's not like, a schizophrenic reality where you're a scientist, the stereotype of scientists during the week and religious on Sunday. But kind of chronologically, I didn't know I had a religious vocation growing up. It was when I was in graduate school that I felt God calling me to this vocation. It was kind of a surprise to me, because that isn't, if you had asked me when I was an undergraduate or starting out grad school, that wouldn't have made sense.
Is there an event or a particular moment that you can say, that's when I realized that, oh, wait a minute, there's something going on?
Yeah, I mean, I had an experience of prayer where I felt God calling me to this. And as I said, it was kind of mysterious or unexpected. But through his grace, I decided to follow up on it. So I went to a priest who happened to be a Jesuit at Princeton. The chaplaincy was run by the diocese, but there happened to be a Jesuit who came down from Jersey City on Sundays to help with the masses.
Who is that?
And his name was Mark DiStefano from the New York province. And yeah, so I started talking to him and kind of went from there.
Did you look at other orders, or did you realize the Jesuits were?
No, that's the other thing I don't quite understand, because what's quite natural and what you normally encourage people to do is to take a look around, take a look at the diocesan clergy, to take a look at the other orders. But for some reason, I felt that this was where I was being called, and
you knew that you were going to finish your doctorate first before you did anything.
Yeah, and that kind of gave me the space and the time not to feel rushed. And the vocation promoters that I was in touch with were very accepting of that and encouraging of that, actually. So I was spending about 3.5 years thinking and discerning, doing come and see weekends, I did a couple of retreats, that kind of thing.
Did you do a postdoc before you entered?
No, I entered 12 days after I defended.
Wow.
Yeah.
So did you find it hard to stay in touch with the field while you were doing the novitiate and the philosophy studies?
Yeah, it was a challenge, but I was intentional about it. I wouldn't say that I entered the society kind of like determined to do science, because as you know, that's not how religious life works, right? And I was really committed to giving myself to religious life. But I knew that might be, well, I'll tell you, one of the vocations directors from Canada, I asked him when I was still a candidate, I'm like, I'm doing this PhD and I hope I'll do what I'm asked to do under obedience, but will my PhD be made use of? And he said something like, you know, I can't tell you how your background and your talents will be used, but I'll tell you one thing, it would be stupid for us not to make use of them. And we're not stupid. So yeah, so when I was doing my philosophy studies, that was in Toronto, where we had a philosopher at the time. And I had colleagues at the Canadian Institute for Theoretical Astrophysics, CETA. And very kind of graciously, they gave me kind of a visiting status. So that, you know, I went to seminars. I wrote one short paper with colleagues there during that time. And then similarly, during theology, I had kind of a similar arrangement. And that was mainly to stay in touch with colleagues. And then also during my formation, I did a 2-year postdoc. So between the philosophy and the theology, I did a postdoctoral fellowship at the University of British Columbia in Vancouver, and that was in cosmology.
As I recall, you built a really wonderfully odd telescope while you were there.
Well, I helped. I wouldn't say I built it, but yeah, it's called CHIME. That stands for the Canadian Hydrogen Intensity Mapping Experiment. And the reason did you say odd?
Yes.
Yeah, is typically, so this is a radio telescope. And if you know anything about radio telescopes, if you think about the Green Bank telescope in Virginia, for instance, or the very famous Arecibo telescope that sadly no longer exists, if you know those telescopes, they're these huge dishes, right? The CHIME telescope, it wasn't the first to do this, but one of the only ones. Instead of a dish that's kind of got this azimuthal symmetry, it's a cylinder, like a skateboarding half pipe. And so what it does is it focuses light in one direction, but then in the other direction, it's flat like a mirror. So you don't have a focal point. Like most telescopes, most radio telescopes have a focal point where you have your receiver. This has a focal line. And so you can put a whole bunch of receivers on it. Now, the reason you do this is with radio telescopes, often you want lots of dishes, and then you combine the signal from all of them. That's called interferometry, as you know. It's cheaper to build one cylinder, put a whole bunch of feeds on it, and then correlate all of those.
Where was this built?
In the Okanagan Valley. So Kelowna would be the biggest city nearby. So kind of, 4 hours east in the interior of Vancouver. Yeah.
British Columbia.
Yeah. And it's there because the mountains help shield you from radio waves produced by human beings, which you don't want to see.
So go even further back then. When you were a kid, were you a science fiction fan? Were you an astronomer, a boy astronomer?
Yeah, I was never like a serious amateur astronomer. So I'm actually kind of nervous with crowds like this because like I can kind of find some constellations, but I'm a cosmologist. So like I don't research stars and constellations and stuff. So no, so I was never kind of really into amateur astronomy, but I was kind of interested in science in general. I don't know if we have any Canadians here, but most kind of science kids or people who grew up in Canada who are interested in science know of Owl magazine, that had kind of experiments you could do and told you about science and had articles and stuff. And that was the kind of stuff I like reading.
Are you an only child? Do you have...
No, I have a younger sister and brother, and they're both married and they have kids. My sister and her husband are teachers. My brother also went the science route. He works for IBM now and does quantum research in quantum computing.
Speaking of going way to the past, let's go to the immediate present. This past week, you've been taking part in a workshop here at the Vatican Observatory in honor of Georges Lemaitre on singularities, space-time, black holes. Can you tell us what that was about and what it was like?
Yeah, so Georges Lemaitre, I'm sure most people on this call know, is sometimes called the father of the Big Bang. And so his personality is kind of the organizing theme of this workshop. But basically what it's looking at are the current frontiers in cosmology. And space, singularities are part of that because we think that the universe began in some kind of singularity or maybe something near a singularity. And one of the research questions is, did it begin in a singularity? That's what the Big Bang is formally. Black holes also have singularities. So by studying black holes, you can get analogs to that. There was also a lot of material on gravitational waves, this new way of studying the universe that began in 2015 with the LIGO Virgo detectors. So a lot of it was heavily theoretical. I'll readily admit that a lot of the talks went right over my head because I'm not a theorist. But there were a lot of talks also kind of on more observationally connected questions. One really big question today is the so-called Hubble tension. So the Hubble constant tells you the rate of expansion of the universe. And there are different ways of measuring that. And over the years, we've been able to measure the expansion of the universe more and more precisely. And over the last 10 years or so, it's become apparent that you get two different values when you use two different ways of measuring the Hubble tension. And the uncertainties were big enough before. If you looked at the error bars, they overlapped and you said, okay, they're consistent. But now it's like way more than 99.9% discrepant. And so this is a really big puzzle. Is there a problem with the measurement? Is there a calibration issue, for instance? Or is the universe telling us something interesting about itself?
How big was the workshop? How many people were there, and who were some of the names?
Yeah, roughly 30 people were there. A lot of big names in astronomy. So, for example, Andrea Linde, one of the pioneers of inflation theory, that really rapid expansion that we're looking for with the Science Observatory, was there. Sir Roger Penrose joined us remotely to give a talk. Adam Rees, another Nobel laureate, who's one of the real leading figures in measuring this Hubble constant, he also gave us a presentation. He was also remote. Wendy Friedman, who's another Toronto native, but now is at the University of Chicago. She's also one of the leading figures in measuring this Hubble parameter. She was there and gave a great talk. Those are just some of the examples off the top of my head.
Trying to think of how many different countries, or at least how many different continents. I know of at least one Jesuit from South America.
Mhm.
We had Americans and Europeans.
Mhm.
There was, I know, at least one Japanese scientist here.
Mhm. Yeah.
It was pretty international.
Yeah, it was. Yeah, and that always enriches a conference like this. Yeah.
Was there any issue in people misunderstanding each other because different fields use the same words to mean different things?
Not so much that, but as I said earlier, there were kind of a broad spectrum of expertises. So I think for those of us who are more observationally inclined, the theory could get quite heavy. I was able to kind of follow the gist of many of the talks, but as I said, the details were a little bit muddy for me. But actually, that's kind of good for someone like me to kind of get a sense of what theorists are working on.
Did you come away with anything that you now are excited about that you want to go back and start looking at that you hadn't thought of before?
I'd have to think about that a bit more, but this Hubble tension is something that we're all aware of, but it kind of gave me fresh vigor, I would say, to work on it, because it's something that the Science Observatory will be able to help probe.
This is fantastic. Well, at this point, we're now getting to the last basically 5 or 10 minutes. If people have questions they want to ask, you can put it in the chat. I've been trying to see if Bob has been putting lots of details into the chat, which is useful. But if you want to ask a question in the chat or just ask a question out loud, feel free to do that. In the meanwhile,
Adam, maybe you could tell us a little bit about your day yesterday.
Oh yes. So as part of this workshop, we had the incredible privilege and honor of having an audience with the Holy Father. So we all got up really early in the morning and went by bus to the Vatican. As you might know, where we are here is about a 5-hour walk, as I explained earlier, from the center of Rome, but we didn't walk. And we were received by the Holy Father. He gave a reflection on the topics of our conference. And particularly talked about Georges Lemaitre and what a great example he is of a first-rate scientist, but also someone who really knew how to intelligently and coherently think about theology, philosophy, and science in a responsible way. And then we all had the opportunity to briefly, individually greet the Holy Father.
One of the talks that I went to very early on was a little bit of history of Lemaitre. And it's fascinating, the simple picture we give of him, I'm inventing the idea of a cosmic seed or, a primordial atom. It's a lot more complicated than that. And he went through all sorts of ins and outs and different ways of thinking about it. But the one anecdote that I remember, and maybe you can help me remember who it was who said it. One of the things that was interesting when Lemaitre had originally predicted the expansion of the universe, where the farther galaxy clusters are, the faster they would move. This was before Hubble had seen it.
2 years before, yeah.
And yet when he translated the paper and put it into a more readily readable version, he removed that, thinking to himself, well, Hubble's done that better than my prediction was. And someone, I forget who, said, that's the sign of a good, humble priest, which is not necessarily the same as somebody who's trying to get tenure or win a prize.
Yeah, well, and, history eventually recognized him because a few years ago, the International Astronomy Union officially changed the name of the expansion law, which he first wrote down the equation for. It was originally called just the Hubble law, and rightly so, because Hubble made the measurement, but now it's called the Hubble-Lemaitre law, because Lemaitre used Einstein's new theory of gravity at the time and actually predicted how the universe should be expanding.
Where do you hope to be in 5, 10, or 20 years? You're still, young in your field, you're still an assistant professor, you don't have tenure yet. You're going through all of that now.
Well, I hope if my superiors want me to stay at the University of Toronto, I hope I have tenure in 5 or 10 years. I hope in 5 years, I hope with the Simons Observatory that we've really shown some very interesting things using the CMB. I hope we've said something interesting about inflation. I think another thing that I'm really excited about is we think that we can say something about the mass of the neutrino. So this is cool because the neutrino is...
I didn't even know neutrinos were Catholics, as the old joke goes. Yeah. I apologize.
Yeah. Well, these are the lightest, the smallest particles. We don't know what their mass is, though. They're so light, they haven't been measured in the lab, but it turns out that their mass affects how structure grows in the universe. And so then rather than measuring the mass of these particles, which wasn't predicted by the theory and which no one has measured, it's not going to be measured in the lab for the first time. It's going to be measured using the whole universe and how these particles affect how structure grows. Now, depending on the details, we might make kind of a marginal measurement, or we might actually measure the mass. And I find that exciting. So hopefully I'll have contributed to that, as one member in a very large collaboration.
One of the things we talk about at the Vatican Observatory is that we get to do orphan science. We get to do long-range projects that otherwise wouldn't get funded. Are you in a position where you can do that? Are you pretty much still in the 10-year grant cycle?
I would say the latter, in the 10-year grant cycle. But maybe a couple of things I'm working on that might, go beyond kind of the 3-year rat race, shall we say. One is one thing I'm doing with the observations that we make with these microwave background telescopes is taking advantage of that first word, microwave. So we're observing a large area of the sky in microwave light. That's wavelengths of millimeters. And what you can do is you can look and see if anything changes from night to night, because we're observing the same part of the sky. And that's called time domain astronomy, where you're looking for things that vary in brightness or that suddenly appear and disappear. And so I've gotten quite involved in that area. And with my PhD student, we're looking at blazars. Blazars are these galaxies that have supermassive black holes in the middle. And those supermassive black holes drive these jets of material that come out. And if they're pointed kind of towards us, they're very bright at our frequencies, and the jets are kind of moving around and there's plasma moving. So they're varying in their brightness over the years. And with ACT, we observed for about 10 years, and with Simons, we're going to be observing into the 2030s. And so one thing I'm interested in is just kind of building up libraries of the millimeter light curves. And that's kind of a you know, at least decade-long project, and that will tell us about the physics of these objects.
You have one other hat at the University of Toronto, which is this membership in St. Michael's.
Yeah, so I'm the first holder of the Sutton Family Chair in Christianity, Culture, Sutton Family Chair in Science, Christianity, and Cultures. Should get that right.
All right.
And so I have this joint appointment, and so it's explicitly part of my job for my teaching to be interdisciplinary. At St. Michael's College, which is fully integrated into the university, so students from any college can study our courses. We have a number of courses in science and faith. And one course that I created, I was asked to create a new course when I arrived, is a course called The Bible and the Big Bang. So it's an interdisciplinary course where we look at early universe cosmology and the Abrahamic traditions of creation. And kind of the big question of the course is, what's the relationship between those two, if any?
Are you doing writing and publishing in that field as well?
A little bit, yeah. So I have a paper that I submitted recently looking at the question of cosmic fine-tuning and how that relates to God. I'm also I'm working on taking my lecture notes from this Bible and the Big Bang course and turning them into a book. So that's kind of hopefully not many-year project. Yeah.
Maybe you'll get a sabbatical and you can come to the Vatican Observatory and do it here.
I'd like that.
You're also active in the Society of Catholic Scientists.
Yeah, so for those of you who don't know, the Society of Catholic Scientists is a worldwide organization of working scientists, whether they're students who are studying science or professors or researchers doing science. And there's an annual conference that just happened a few weeks ago. I didn't go to it. And then locally, we organize chapters. So in Toronto, we have a local chapter. We have a gold mass every year, kind of analogous to the red masses of lawyers. And we organize talks and other events.
And finally, as somebody here asks, your picture of cosmology that you're describing is mind-bending for a lot of people. What kind of public outreach do you do, or what can you recommend to either people in this audience or have them recommend to when they do public outreach in trying to get across some of what we're learning about cosmology to the general public?
Yeah, so is the question about the science-faith interface or about kind of cosmology?
Both. Either or both.
Yeah, so I mean, there are lots of great books out there on kind of introducing cosmology, pure cosmology. So for instance, I have a colleague, Jo Dunkley. She's a professor at Princeton University, and she wrote a really nice introduction called Our Universe. And it kind of introduces you to cosmology. So and there are many other great examples like that. For kind of the science-faith relation, yeah, I give talks. I give talks on the Vatican Observatory, for instance, because I'm an adjunct member here. Why is there not a Vatican Observatory? I give talks on kind of cosmology and creation. In terms of material, I have a number of articles in America magazine that look at various aspects of science and religion. I highly recommend your book that you wrote with Father Paul Muller, Would You Baptize an Extraterrestrial? I think that's a really good and accessible, but also intelligent resource. So those are a couple of things that come to mind.
Okay. Well, we have now reached the end of our usual period. We try to finish up at about 10:02. I'm delighted that you're able to join us. And I just am thrilled at the way you very casually talk about these incredibly big questions of who we are, where we come from, and what it's all about. And you can tell from the way you talk about it, the joy that you have and the joy you experience in doing this work. So thank you
You're
for
welcome.
sharing some of that joy with us today.
And nice to meet all of you.
Last chance for any questions? All right. Well, we will see you then all on next full moon. Talk to you then.
That'll be the first full moon of our new fiscal year, as our board chairman would like me to mention. So
Indeed. Okay.
Thank you.
all right. Thanks, Larry. Thanks, Bob. Talk soon.